and welcome to the red planet, Mars. This thing is half the size of Earth, but has the same amount of land. This thing is half the size of Earth, but has the same amount of land area, most of which is covered in reddish iron oxide dust. A Martian day is nearly the same as Earth's, at 24 hours and 37 minutes. This should be very convenient for any humans that eventually live on Mars. Mars happens to be tilted a bit, just like Earth. So it effectively has seasons, although the seasons are much longer here because a year on Mars is twice as long. And due to the distance from the sun, Mars is more inhospitable than Antarctica, but it is still the friendliest place that isn't Earth. It has extremely cold temperatures as low as minus 143 degrees Celsius, but in certain cases, temperatures can reach as high as 35 degrees. Or 95 degrees Fahrenheit. This is a very healthy overlap with temperatures that are familiar to us on Earth. On the whole, though, average temperatures on Mars are well below freezing. And there are lots of glaciers all around Mars, and they're all covered in a layer of dust, and they are protected by this dust. And based on what we now know, it is thought that the ice in all of the Martian glaciers is equivalent to what could cover the entire surface of Mars with 1.1 meters of ice. That's a lot. In addition to the glaciers, there is actually a lot of water ice in the soil. So if you were to dig 1 meter down, anywhere in the top or bottom third of the planet, maybe half of the material that you excavate will be water ice. So today, when the occasional crater is formed, it exposes ice to the air, and the ice stands out pretty easily, but it usually evaporates within months. Mars is named for the Roman god of war, which originally came from Greek mythology, where the god of war was named Ares. As such, sometimes you'll hear about Mars-related things as Martian or Aryan. But before I go into more detail about the planet itself, allow me to point out Mars's two very small moons, Phobos and Deimos. Phobos, the bigger of the two, is a dark moon and is the closest moon to its planet out of any in the solar system. Its name comes from the Greek god of fear. Despite being a 27-kilometer wide rock, around 30% of Phobos' interior is hollow. And there is an unusual building-sized boulder sitting on its surface, informally known as the Phobos monolith. There's Phobos now. That monolith is 85 meters across and 90 meters tall, and it has been suggested as a landing site so that we can find out exactly what it is. The other moon, Deimos, is smaller and much smoother. That moon is named for the Greek god of dread and terror. Both of these gods accompanied their father Ares into war, which is why you see them all together here. Both moons were discovered in 1877 by the astronomer Asaph Hall III, and he also determined the mass of Mars from the orbits of those two moons. Okay, let's continue. So, Mars is... So here we have Ceres. This is the first dwarf planet that we'll visit on our journey, and it is the largest asteroid in our solar system. Ceres is named for the Roman goddess of agriculture, and most of its surface features have names that are derived from the themes of harvests, fertile lands, and gods and spirits relating to such things. The symbol for Ceres looks like a scythe, like the kind you would use to cut your fields. The word cereal, the kind that you eat, is based on Ceres. Out of all the hundreds of thousands of asteroids that we've discovered so far, this was the first one to be discovered in 1801. In fact, it's the first minor planet to be discovered, so its official name is 1 Ceres. Minor planets are basically any solar system body that isn't a planet or a moon. And then this is the only asteroid to be classified as a dwarf planet, because it is the only one to be in hydrostatic equilibrium, which simply means that it's massive enough to be able to pull itself into a roughly spherical shape. So, for a very good long time, the only picture we had of Ceres was a blurry one, put together by the Hubble Space Telescope in orbit around Earth, which revealed a small ball with a very curious bright spot. And then finally, very recently, we were able to explore Ceres up close from 2015 through 2018, when the NASA spacecraft named Dawn approached and entered orbit. Dawn had used its ion engines to first explore Vesta, the third largest asteroid we know of, and then it moved on to Ceres, where it now slings around in an uncontrolled orbit for at least, say, the next 20 years or so. The spacecraft was able to shift orbits several times and get really close, at one point coming within 35 kilometers of the surface. So it is no wonder that we now have stunningly gorgeous photos of Ceres with about 1,000 times better resolution than what Hubble was able to capture. And now we have great shots of those bright spots, which can be found in the floor of Okator crater right here. So what are those bright spots then? Well, unfortunately, they are not alien city lights, as many were hoping. After some study of the massive amount of data collected from the Dawn mission, researchers have determined that the bright material is made of sodium carbonate. In other words, washing soda, or soda crystals. We already use this stuff on Earth to make glass, paper, washing detergent, and so on. It's basically salt plus limestone. Several lines of evidence point to a very recent episode of cryovolcanisms in a low-density region below this crater, pushing the material up onto the surface. And so now that bright spot in the center of the crater is named Cerealia Vacula. Even better than identifying the bright spots, though, is that researchers have discovered that Ceres used to have a very significant subsurface ocean liquid water, some of which may still be there. By now, though, most of that water is now.
This is Jupiter. This giant planet comprises the vast majority of the planetary mass of the solar system.
And it is massive enough to have the gravitational pull that can tug on the sun itself. So observers from other star systems could employ a technique called radial velocity, and they would notice our sun wobbling a little bit over time, and from that could deduce the presence of Jupiter. Things don't sit still for very long on Jupiter. It's a gas giant, and it is made of the same substances as our Sun, 98% hydrogen and helium, mostly in highly compressed liquid form deep in the interior of the planet. There's no solid surface, and we now know that even its core is a giant, partially dissolved, fuzzy mess. Jupiter was originally twice its current size. Let that sink in. The largest planet in the solar system by far used to be twice its size. Wow. It has been shrinking at a very slow rate due to gravity crushing the energy out of atoms in its core. And this energy continues to stir up the atmosphere, giving rise to all of these stormy cloud belts. On top of that, this giant planet rotates stunningly quick, with one rotation every 10 hours. These cloud belts slip past each other at different speeds in different directions, fluidly mixing their gases at their boundaries. You're probably familiar with the Great Red Spot. It is a distinguishing characteristic of this planet wherever you may see it in the media. The Great Red Spot is continually changing its color every few years, with hues ranging from brick red to white. The surrounding cloud belts also change their colors from time to time. So sometimes the Great Red Spot can look like it's disappeared, even though it's still there, blending in with the cloud belts, and it is turning as hard as ever. And even though it is still huge, the Great Red Spot has been Come to Saturn, which is a special place that captures the imagination like no other because of the grand views of the rings, the storms, all the interesting moons, and all of their associated phenomena that you just don't see anywhere else. There is far too much to talk about here, but I'll keep this short as I know you're anxious to take a closer look at the Saturn system. First, I want to talk about the planet itself. It is extremely hot in its interior. So although it's relatively plain looking, there's actually a lot of activity in the atmosphere. It's got active cloud bands that are a bit harder to make out than on Jupiter, but every once in a while there are some unmistakable storms that show up, like one that is known as the Great White Spot. It shows up as a spot, and then it twirls all the way around the planet, forming a relatively bright white stripe that just goes all the way around. And throughout the 20th century, this great white spot appeared once every 30 years, almost on the dot. But then, after 1990, it started to appear much more frequently, for some reason. It hasn't been seen since 2000.